A system is taken from state A to state C, B, Y, two paths. Here A to C, B, Y, two paths are there here. A, D, C and A, B, C. A, D, C and A, B, C. This is one path and this is the another path as shown in the figure. The internal energy at A is UA, that is 10 joules along the path ADC. The amount of heat observed, that is delta Q1, that is amount of heat observed is 50 joules and the work obtained is delta W1 is 20 joules. Whereas along the path ABC, the heat observed delta Q2 is 36 joules. The amount of work along the path ABC, in this one, that is delta W2, we need to find here. This is the question mark here. We need to find this one. Okay. Now, we know that according to the law of thermodynamics, there is first law of thermodynamics, we can write that is a delta Q is equal to delta U plus delta W. That means change in heat transfer is equal to change in internal energy plus change in work done. Okay. Along the path ADC, in this direction, the first path if I am going to take here, ADC, that is a delta U1 is equal to delta Q1 minus delta W1. If I substitute the values, that is 50 minus 20 is equal to 30 joules. Then along the path ABC, the change in internal energy, that is delta U2 is equal to delta Q2 minus delta W2. Then if we don't know the value of the delta U2, but the change in internal energy, it is a path independent, then we can say that delta U1 is equal to delta U2. As the internal energy, it is a path dependent, it is the which the path function. Then delta U1 is equal to delta U2. Then we can write this one as delta U1 is equal to delta U2. Okay. And this value we know here, that is the 30. Delta U2, I am going to take it as a 30 now. And delta U2, we can write it as delta Q2 minus delta W2. Delta Q2 is equal to 36. Then I can take this delta W2 to the LHS. That is delta W2 is equal to delta Q2 is 36 minus 30. We get the answer, that is 6 joules. That means the change in work done, that is the delta W2 is equal to 6. This is in the option D. Option D is the right answer.